So hello guys and welcome to the another video of GFG problem of the day, that is maximum of minimum for every window size. Believe me, this is one of the hardest question we have ever going to do today, because I don't think so that the 45 minutes is enough for this problem, as they have given the average time as 45 minutes to solve. But let me tell you one thing, there are so much thing to learn from this question, so I highly recommend you to stay till the end of this problem. The goal of this video is not to solve this problem, but the goal of this video is to identify how we can solve such type of problem, right? So let's first start with by identifying the meaning of the question, right? So what does the basically question says that we have given an array called as ARR, and what the task we have to do is we have to find the maximum of all the minimum values for every possible window size, whereas the window size ranges from 1 to the size of an array. Okay, now most of the people might feel difficult to identify or get the meaning of the question. Don't worry, let's try to get the meaning of the question by one example. So I have given one array, and let's take an example. The window size is as 3. The window size is 3. So what are the different subarrays of size 3 we can get? We can have 10, 20 and 30. This is one subarray. We have 20, 30 and 50. We have 30, 50 and 10. We have 50, 10 and 70, and we have 10, 70 and 30. Now what they have told is get the minimum of every single subarray. Get the minimum of every single subarray. So minimum is 10 over here, minimum is 20 over here, the minimum is again 10 over here, minimum is 10 over here, minimum is 10 over here. Now what they have told us? What they have told us? The maximum of all the minimum values. So what now we have to do is whatever the minimum values we have got from every single subarray, take the maximum from it. So which is the maximum? 20. Which one is the maximum? 20. So let's try to do this for another subarray. Let's example, if I take the subarray of size as 4. So what are the subarrays we can get? 10, 20, 30 and 50. This is one subarray. Then we have 20, 30, 50 and 10. Then we have 30, 50, 10 and 70, and we have 50, 10, 70 and 30. So these are the subarrays we can have of size 4. Now again get the minimum of every single subarray. So 10 is the minimum from this, again 10 is the minimum from this, 10 is the minimum from this, and 10 is the minimum from this. So which is the maximum of all? Maximum of all is nothing but 10. So in this way, for every single subarray size, that is the size of subarray should be 1, 2, 3 up to n. For every single subarray we have to follow the same procedure. Get all the subarrays of size 1, 2, 3 up to n, get the minimum from every single subarray, and at the end get the maximum of every single minimum values, right? So let's try to understand this problem more deeply. So here what I have done is I have written all the subarrays of every single sub size, right? The subarray of size 1, subarray of size 2, all the subarrays of size 3, 4, 5, 6, 7, because the size of array is 7. Therefore the total subarray size will be from 1 to 7. So if you observe carefully, these are the subarrays of size 1, these are the subarrays of size 2, these are all the subarrays of size 3. In this way I have written all the subarrays. Now let's try to identify something. So these are the subarrays. Now which one is the minimum? 10 is the minimum, 20 is the minimum, 30 is the minimum, 50 is the minimum, 10 is minimum, 70 is minimum, and again 30 is minimum. And out of which one is the maximum? 70. So basically I wrote 70 over here. Now let's go to the subarray of size 2. Which one is the minimum? Which one is the minimum? 10 is the minimum, 20 is minimum, 30 is minimum, again 10 is minimum, 10 is minimum, 30 is minimum. And out of which one is the maximum value? 30. That is the reason why I wrote 30 over here. So let's move on to the subarray of size 3. So which one is the minimum? 10, 20, 10, 10, 10. Which one is the maximum? 20 is the maximum. So answer is 20. Subarray of size 4. Which one is the minimum? So everywhere the minimum is 10. So I wrote 10. Subarray of size 5. Which one is the minimum? 10, 10, 10. And out of which one is the maximum? Of course 10 is the maximum. Similarly for size, minimum is 10, minimum is 10, maximum of 10, 10, 10 itself. So answer is 10. And all this, which one is the minimum? 10, and maximum is 10 itself. So 10 itself. So the answer is 10, right? So now I hope so you clearly understood the meaning of this question. Now what I will do is I will just go and write the brute force solution. But don't worry, I'm not going to write the brute force solution directly. Whatever the things I'm going to write it, I'm going to write it based on the observation. So let's try to observe something. So these are the sub arrays I wrote, right? So these are the sub arrays ranging from 1 to 7, because the size of my sub array should start from 1 and it will go till my n. So this is what I wrote. So what I will do is I will simply name it as an I equals to 0, I equals to 1, I equals to 2, I equals to 3, I equals to 4, I equals to 5, I equal to 6. So total how many sub arrays are possible for any array of size n? What is the total sub arrays of possible for any array of size n is nothing but from I equal to 0 till n minus 1. So what I will do is I will simply write the outer loop which starts at 0, I equals to 0, and it will go till less than n, and simply I will do I plus plus. Okay, so we understood the total number of sub arrays. Now total number of sub arrays. Now for every size how many sub arrays will be there? For example, if the size of my sub array is 1, then how many total number of sub arrays will be there? 1, 2, 3, 4, 5, 6, 7. Okay, so here I got 7 sub arrays. Now for the size of sub arrays 2, how many total sub arrays are possible? Here there are 6 sub arrays are possible. For size of sub arrays 3, then how many total sub arrays are possible? The total sub arrays are possible is 5. Here I have 4, here I have 3, here I have 2, and here I have 1. Right. So how we are getting this? How many total sub arrays will be there of size k? Right. Now observe carefully that the size of my array is nothing but n. The size of my array is nothing but the n, and here the value of I is 0. So if I do n minus 0, that is nothing but 7 minus 0 is nothing but 7. So whenever the I equals to 0, there are total 7 sub arrays are there. Okay. Whenever the value of I is 1, so 7 minus 1 would be 6, therefore total 6 sub arrays will be there. Whenever the value of I is 2, if I do 7 minus 2, it would be 5, so there are 4, total 5 sub arrays will be there. So now I hope so you understood on what basis we can say that how much total sub arrays will be there of size k. So simply based on the observation, whatever we have observed, I am writing a loop which start from j equals to 0 and it will go until n minus 1 and I will do j plus plus. Right. This is a simple observation we got. Now we came to know that there are total 0 to n minus 1 sub arrays will be there. And for every size k, we also came to know that how much sub arrays it would be possible. Now we need to figure it out. What is the size of my array? What is the size of my sub array? Again, it is nothing. It is simple observation. See, if you observe carefully, the value of I is 2 and the size of sub array is 3. The value of I is 3 and the size of sub array is 4. The value of I is 4 and the size of sub array is 5. So can I say that whatever the value is, it would be plus 1. Whatever the value of I is, it will be a plus 1, the size of my sub array, right? See, the size of I is 1, so size of sub array is 2. I is equals to 5, the sub array size is 6. I is equal to 6, so sub array is of size 7, right? Now we also got to know what is the size of our sub array. Now what is the one thing that we need to find out? What is the one thing that we need to figure it out? From where it will start and where it will end. Say for example, I am taking this one, right? Let me erase this. So what is happening is it will start from index 0, 1, 2. Again it will start at 1, 2 and 3. Right. So if you are standing at 1, you have to go till 3. So let's check it out how we can get this. Now what is the size of my sub array? I plus 1. That is I plus 1. Okay, so let me write over here. So I will simply write I plus 1 is the size of my sub array, because the value of I is 2. So 2 plus 1 is nothing but 3, and we can observe this, the size of sub array is also 3. And I will go from 1, 2 and 3. But the 2 plus 1 equals to 3 and I have to go till 3. So I will simply add the j in it. Now see, what is the value of j over here? This is 0 and this is 1, right? Because this is my first sub array and this is my second sub array. What does j indicates? Total number of sub arrays. So this is my second sub array. So 1 plus, what is the value of I? 2 plus 1, which is nothing but 4. And what the condition will be? It would be less than 4, which is nothing but 3. So what basically I will do is I will simply run a loop. Let's call it as a k. So k equals to 0. I will go as k is not equal to j plus I plus 1, and I will simply do k plus plus. So this is what a simple code will look like. Now what we need to do is we need to generate all the subarrays. We need to generate all the subarrays and pick the minimum from them. Right. So let's do this. So what I will do is I will simply keep a variable called as a num, which is initialized to 0 because I want to have the maximum number, right? So num, sorry, not 0, it would not be 0 because I want to have the minimum number. So let's initialize with maximum number called as 1e9. So what I will do is a num equals to minimum of num comma ar of k. So this is where I will get the minimum number from every single subarray. From this is the minimum, from this minimum, from this minimum, from this minimum. And once you find minimum, what we need to do? Once we find the minimum, what we need to do? We need to update the maximum from all the minimum. So simply what I will do is once I come out this loop, I will update as answer equals to I equal to maximum of answer of I comma num. So whatever the maximum we get, we will simply store. So this will loop over here and this loop will end over here. This is a simple observation based brute force solution we wrote, right? If you observe carefully what we did, we basically generated all this subarray, and from which we got the minimum. We got the minimum from every single subarray, and at last from all the minimum we got the maximum, like 10, 20, 10, 10, 10. Which one is the maximum? So 20. So the same thing we did over here. First of all, we found the minimum from all the subarrays, and out of which we basically found the maximum from all the minimums, right? Now what will be the total time complexity for this brute force solution? It is nothing but big of n cube, because this loop might go up to the n. Of course it will go till n. Approximately this will also go till n, and approximately this will also go till n. Therefore the total time complexity would be big of n cube. Now when you try to submit this code, will you think that this code will be accepted? Of course no, right? So now let's try to optimize this code. Now again, what we basically did is we basically generated all these subarrays. First of all, size 1, then 2, then 3, then 4, then 5, up to n, right? We generated all the subarrays from 1 to n. Now we will not generate every single subarray. Instead of this, what we will do is we will ask for every single element that are you the smallest element for how much subarrays? For how many subarrays you are the smallest number? So let's start with 10. So 10, for how many subarrays you are smaller? It is also smaller for subarray of size 2, subarrays of size 3, smaller than 50, smaller than or equal to 10, smaller than 70, smaller than 30, which means 10 is smaller for every subarray, right? 10 is smaller for every subarray. And initially what I did is I have initialized my answer array at 0. Now what I told you, once we get the minimum, what we need to have? We need to have the maximum, right? We need to have the maximum from this. So basically I'll simply update it to 10. I'll simply update to 10 because 10 is greater than 0, right? 10 is greater than 0. Now again, so we have done with 10. So let's move on to the 20. Now I will ask to the 20, hey 20, you are smaller for how many subarrays? So 20 says I'm smaller than 20, okay, smaller than 30, smaller than 50, but it is not smaller than 10, okay. So which means it is smaller for 3 subarray of size 3. So let's write it as it was 20, 20 and 20, right? Now see what happened. Here we have 10 and we got the new value as 20. Now which one is the maximum? 10 or 20? Of course, right? 20 is maximum. So simply I will erase this and here I will write 20, 20 and 20. Okay. Now we have done with 20 also. Let's move to the next, that is 30. Now ask to the 30, hey 30, you are smaller for how many subarrays? So am I smaller than 20? No. Am I smaller than 50? Yes. Am I smaller than 10? No. Which means 30 is smaller for only 2 subarrays. Okay, write it as, so I have 30 and 30. So now we already having 20, now we got 30. So which one is the maximum? Of course you guessed it right, that 30 is maximum. So I will simply update it as 30. Now we are also done with 30. Now we will move to the 50. I will ask 50, hey 50, for how many subarrays you are smaller? Here it says I'm not smaller than 30, I'm not smaller than 10, so I am only smaller for only one subarray. Here I will simply write it as 50. Now see, 50 is greater than 30, so simply I will update it to as 50. Now again I will go to the 10, and 10 will says I am smaller for everyone, because 10 is smaller than 70, smaller than 30, smaller than 50, smaller than 30, 20 and 10. So it is smaller for everyone, right? So again I came at 70, and I have already written 10 for everywhere, right? I have written 10 for everywhere. So let's move on to the 70. Now let's check. 70, you are smaller for how many subarrays? I am not smaller than 30, I am not smaller than 10. Therefore it is smaller for only one subarray. So I will simply write 70. Now 70 is greater than 50, so simply I will update over here as 70. Now I will come to 30. Hey 30, you are smaller for how many subarrays? 1 and 2. It is smaller for only 2 subarrays, so it will come as 30, and here it will come as 30. So already 30 is not greater than 70, so I will not update it. Again we have 30, 30 is greater than equal to 30, so it will remain as it is. So this is our final answer. This is our final answer, and see, 70, 30, 20, 10, 10, 10, 10. If you try to compare over here, 70, 30, 20, 10, 10, 10, 10. Right. Now, basically what we are doing is, we are moving for every element. We are going at every element, and we are trying to check if this element is smaller for how many subarrays. Now, if you figure it out that 10 is smaller for every single subarray, so again what we are doing is, we are moving to answer and updating 10 at everywhere. Now we go to the 20, and again we are checking 20 is smaller for how many subarrays. Now we came to know that 20 is smaller for 3 subarrays. So again you are going and updating. Now you got a 30, you came to know that 30 is smaller for 2 subarrays. Again you are updating. So for every element you are trying to update. Whole answer array. So what will be the total time complexity for this? The total time complexity would be big of n square, because you are traversing this array, and also at the same time you are trying to update this array one by one. So again this will give us time limit exceeded. Now, can we optimize this from big of n square to the n? Let's try to identify. Now let's try to optimize our code from big of n square to big of n. So what basically we try to did over here is that for every element we were trying to check for what is the size of subarray for which this 20 is smaller, right? So 20 is smaller for the subarray of size 3, because observe carefully, 20 is smaller than 30, smaller than 50. Now, if I consider the 10 in my subarray, will my 20 will be the smallest element? No, because 10 will be considered as the smallest element. Therefore, what basically we are trying to do over here is that for every element, I am trying to find the smallest element towards its right side and the smallest element towards its left side. What we are trying to do is the smallest element to its right side and the smallest element to its left side. For example, let's suppose you are standing at 20. Now, let's suppose I wrote a 20 here. Which one is the smallest to right side? Right smallest. Which one is the right smallest to the 20? Of course 10, which is its index is 4. What is its index? 4. Now, which one is the left smallest? Which one is the left smallest to the 20? Of course 10, which is index 0. Now, I want to figure it out that I came to know that 10 is the smallest element to the right of 20, and this 10 is the smallest element to the left of 20. Now I want to figure it out for what is the window size for which 20 is the smallest. By the naked eyes, I came to know that this 20 is smaller for this window. 20 is smaller for this window, that is size 3. So, but I got this next smallest element at 4 and the previous smallest element at index 0. So can I do 4 minus 0 minus 1, which is nothing but 3. So 20 is smaller for window size of 3, right? Whatever the color I marked it. Now let's suppose I want to figure out for 30. So what I will do is, for 30, which one is the right smallest? For 30 at index 4, right? Because 10 is smaller than 30. So index 4. Now which is the left smallest for 30? 20, which is at index 1. So minus 1, which is nothing but 2. So I can simply say that 30 is smallest for window size of 2. Okay, so from the left smallest and the right smallest, we came to know that how we can identify for any particular element this is smallest for how much window size. Okay, so what basically I did over here is that for every single element I have figured it out, the previous smallest element and the next smaller element. For every element I have already figured it out. So let's try to identify. So first I will go to the 10. Now I will ask, hey 10, for how much window size you are smaller? So go to the next, that is 7 minus minus 1 minus 1, so it would be 7. So 10 is smaller for whole subarray, so right, so I have the 10, so 10 is greater, so write 10, 10 is greater, 10 is greater than 0, so everywhere I will update it as 10, everywhere I will update it as 10. Okay, so I'm done with 10. So let's move at 20. I will ask 20. Hey 20, you are smaller for how much window size? Okay, so 4 is my right smallest, minus 0 minus 1, which is nothing but 3. So 20 is smaller for 3 window size. See, 20 is smaller for 3 window size, that is 20, 30 and 50. So go and update for 3 window size. 20 is greater than 10, 20 is greater than 10 and 20 is greater than 10. Okay, now I'm done with 20. Let's go to the 30. 30, you are smaller for how many window size? So index is there 2, so index is 2. So next smaller is 4, previous smaller is 1 minus 1, which is nothing but 2. So 30 is smaller for window size 2. So let's update 30 is greater than 20, 30 is greater than 20. Okay, I'm done with 30. Let's move to the 50. Now I'll ask 50, you are smaller for how many window size? So index 3 is 4 minus index 3 is 2 minus 1, so which is nothing but 1. 50 is greater element only for window size 1. So let's update. So let me erase this, right? So I have at 50 and here I have 30. Now we come at 10. So 10 is greater for every element. We have already discussed, right? 10 is greater for every element. Let's move to the 70. Now 70, 6, previous smaller is 6 minus, next smaller is 6 minus previous smaller is 4 minus 1, which is nothing but 1. So 70 is greater for only one element and 70 is greater than 50. So simply I will update it. Now 30 is smaller for two elements, that is this. Now 70 is greater than 30, no. 30 is greater than 30, no. So this is our final answer. But again, what we are doing is, I came to know that 20 is smaller for two window size. So 20, 20, 20. 10 is greater for all the window size. So 10, 10, 10, 10, 10, 10. So again, what I'm doing is, I'm again following the same process. So instead of, so whenever I get the, let's observe something, right? Whenever I get the window size for which the number is smaller, for example, if I get as 20, let's get the 10 first. So which is the next smaller for 10? That is 7 minus, which is the previous smaller, minus 1 minus 1. So it would be 7. So instead of assigning 10 at every window, what I will do is, I will assign it at last. So I will simply keep it as 10. Why? Because for the remaining while, I will go on optimizing it slowly. As I move forward to my array, for this remaining part, I will keep on going optimizing it. Okay. For the 10, I have done with 10. Now I come at 20. So I will check how many, for what is the size of sub array for which 20 is smaller. So next smaller is 4 minus previous smaller is 0 minus 1, which is nothing but 3. So 20 is smaller for sub array of size 3. Okay, so let's go and update at sub array 3. So here I will simply update it as 20, right? See, I'm not updating for every sub array, no, only at the last position. The size was 3, so I updated over here. So I updated over here. Similarly, I will go at 30. 30, you are smaller for how many sub arrays? So 4 minus 1 minus 1, that is 2. So simply go and update at 2, that is nothing but 30. Now I came at 50. 50, you are smaller for how much? That is 4 minus 2 minus 1, 1. So simply go and update 50 over here, that is 1, right? I came at 10. 10 is greater for everyone, so I already updated 10. I came at 70, right? So what is 70? 5 minus 4 minus 1, 6 minus 4 minus 1, that is 1. So 70 is greater than 50, so simply update it. Now I came at 30. So what is 30? 7 minus 4 minus 1, which is nothing but 2. So let's update. Is my 30 is greater than equal to 30? No. So simply keep it as it is. Okay, we have updated it. Now the big question comes in. What are these about remaining values? Observe carefully. It contains 10, which means, can I say that if I stay at here, is my 0 greater than or equal to 10? No, 0 is not greater than 10, which means 10 is greater than 0, right? 10 is greater than 0, so simply updated 10. Now which one is greater, 0 or 10? 10 is greater. Now you are standing at here, which one is greater, 0 or 10? 10 is greater. Now you are standing at here, which one is greater, 20 or 10? 20. You are standing at here, which one is greater, 30 or 20? 30. you are standing at here. So what we are doing is we are comparing this value with this value with this with this with this. So every previous element is getting compared with this next element. Whatever the maximum comes in, we are simply updating it. So that was the real question. Now I haven't discussed anything about previous molar and the next molar, because if I try to explain this, the length of my video goes on increasing. If you want to know that how we can get the previous molar and the next molar, do let me know in the comment section. I will make a separate detailed video on it. As of now, we will move to the IDE and we will try to figure it out how we can write the code for this problem. So this is the code I wrote here. So first of all, what I did is I simply got the length of my array. Then I declared the two arrays to find the previous molar and the next molar, right? And these are the two functions I have wrote to get the previous molar. Let me show you. So this is the function to get the previous molar. This is the function to get the next molar element. Once I got the previous molar and the next molar, what I did basically is we figured it out for every element for how much window size it is smaller. See, the next molar of I minus the previous molar of I, minus 1, right? This is what we did. And what basically we did is, if we got the window size is at 3, so instead of updating at all the places, we updated at last place. But also at the same time, I need to figure it out that I want the maximum element, right? That is the reason why I took the maximum of the current element and the new element which is coming. Whatever the maximum is, I'm simply updating at last position, right? If my window size is 3, I will directly put that maximum element at size 3, not at 1, 2 and 3. And again, as we discussed earlier, what we did is from backside we keep on traversing and we checked if this element is greater or the next element is greater. So whichever which is greater, we simply kept it into my array. And finally, I simply converted this normal array into the array list and I simply return it. So this was the code wise, it was really simple, but from understanding point of view and intuition and the approach point of view, it was a bit hard problem. But indeed, this was really a good question. Just in case if you are new to our channel, do subscribe to channel for the daily problem of the day solutions in detailed explanation about the data structures in Java. Till then, see you tomorrow in the next video.